Hello students. In the previous lecture we have been discussing about the physical, the chemical and the biological properties of water. Right. Now there is another topic which is called water quality standards. This topic is very important for you because since it has been decided that you will have objective type questions in your examination, many of the questions will arise from the water quality standards. Water quality standard, when we talk about water quality of standard, there can be two types of water quality standard. The first type of water quality standards can be the water quality standards for drinking water or for potable water. So you can be asked concentration, the permissible limits of various chemicals or various metals or various impurities in water which are to be used for drinking purpose, right? And then you can also have the water quality parameters for effluent water, right? So as we have discussed that water can be called an influent water or effluent water. Influent water is basically what is the sewage or what is the polluted water that is coming inside a treatment system, that is called an influent. And after the treatment by various physiochemical processes, the water which is coming out from the system is called the effluent water. So we don't have too much control over the influent stream because the nature of wastewater can vary differently and it can be of various concentrations depending upon the source from which the polluted water is coming, right? So depending upon the source, the physiochemical processes involved in wastewater treatment would be different for different type of water streams, right? For example, if a water which is influent water which is coming from say an industry which is using animal products like the slaughterhouse or like the skin hide industry, right, the leather industry. So that industry is expected to have oil and grease in it, right, in the influent, and that can affect the systems which are biological systems, right? For example, if in an aerator chamber a large amount of oil and grease is coming, it can affect the population of the bacteria in the aerated lagoon or aerated system, right? So what actually happens is that in such system what we will do is we will use another system which is called DAF or dissolved air flotation system. These systems we are going to discuss in the further classes or in further units in detail, but for now I can just tell you that a dissolved air flotation system is basically used for removal of fat and grease from the influent stream before that influent stream can go to bacterial processes or aeration process or clarifier, right? So that it doesn't affect the physical parameters and physical characteristics of other treatment systems, right? So basically what I am telling you is that depending upon the type of influent and the source of pollution of the influent, we can have many types of pollution treatment systems, right? ETP, STP, for example, if you are treating a municipal waste, like the waste that is coming from your household or that is coming from colleges or from any such place where nothing is produced, basically a municipal sort of waste, domestic wastewater. So we can use sewage treatment plant for that. But for any industry we will have to use ETP, that is effluent treatment plant, which will have things which will be directed towards the treatment of that very influent which is coming inside. Depending upon the type of influent which is coming inside a stream or which is coming with a stream into a system in effluent treatment plant, we have a set of effluent parameters, right? So effluent parameters are different from the parameters of drinking water. Effluent is to be discharged in a water stream or effluent is to be discharged into a river. So it does not necessarily have to be in the quality of drinking water, but for the drinking water we will have a different set of instruction, we will have a different set of parameters which should be followed. That for example COD should not be less than that, BOD should not be less than that. So our system that is treating influent will have an effluent of different properties, and depending upon those properties the effluent consideration and the effluent concentration is defined differently than the properties of a drinkable wastewater or drinking water. So if we are going to make the wastewater, for example, we want that water should be reused for washing purposes. So for washing purposes it does not necessarily have to be very pure, right? We just are using it for washing purposes or for gardening purposes. So it can have higher proportions of items which are otherwise non-negotiable in drinking water, right? But if we are to reuse that water for drinking purpose or for cooking purpose or other potable uses, then we'll have to treat that water so much so that it becomes just like fresh water, right? So we have technologies like membrane batch reactor or moving bed biological reactor, which can give us the effluent concentration up to the order of drinking water also, right? For example, ultrafiltration and nanofiltration and MBR, these will give you effluent characteristics which will make the sewage water and take the concentration of various physical properties and various chemical and biological properties to a level that it can be used for potable purpose also, right? So depending upon what type of usage we have different type of water, and we will have different type of physiochemical and biological processes and properties for that water. So when objective questions are going to be asked, so most of the questions can be from water quality standard, but you have to make sure that the water quality standards for drinking water and water quality standards for effluent water stream are different. So you will have to memorize it before going into multiple choice question exams, right? So now we will delve into what water quality standards are and what are different types of water and what are their uses. So let's see. The definition of water quality depends on the intended use of the water. As I have been saying in this video, that intended use of the water signifies the properties of water, which may be either human consumption or it may be for industries, irrigation and recreation purposes, right? So depending upon what are the intended purpose of treating that water or what are the intended purpose of the usage of that water, the water quality standards may vary, right? Depending upon the proposed use of water, certain water quality criteria is established, and based on these criteria, quality standards are specified by health and other regulational agency. So what are we basically dealing with are that regulatory bodies. For example, for Government of India, Central Pollution Control Board is a regulatory body, right? So CPCB has specified limits for different type of physical properties for a water to be discharged into a river stream, right? Like an effluent is to be discharged in a river stream, then it should comply with the standards given by the regulatory CPCB, right? So different type of uses require different level of water purity. Drinking water requires highest standard of purity. This is you already know. So what is pure water? Pure water is that water which contains only 2 parts of hydrogen and 1 part of oxygen. Pure water is a water from a source that has removed all impurities. It either doesn't have the impurities from the start, or if it had the impurities, it has been treated to a limit where it is acceptable for potable purpose. That water is pure water. And the one of the most purest form of water is distilled water. So pure water can be used for cooking, drinking and scientific studies and laboratories. Distilled water, basically what we do is we use pure water for our potable purposes, and distilled water used in laboratories only, right? So what we do to get the distilled water is, the distilled pure water is the water that is produced by a process which is called distillation. This water is boiled. The water is continuously kept on boiling, and when the water boils, the stream is formed, and that stream is then condensed into a container to get distilled water, right? So we are basically condensing the stream to get the distilled water, and this is the purest form of water that is available to us, and this is mostly used in laboratories, right? Another form of pure water is de-ionized water. Distillation is a time taking process, and it's costly as well. So what we do is we seldom use de-ionized water. Basically what you do is ion exchange is a physical process that uses resins to remove minerals and salts from water. So de-ionized water is also used in laboratory purpose only. It is not used for potable purpose. For potable purpose, the groundwater is the best form of water that we take out, or either if the source of water is at a distance, and then the water distribution scheme that we had discussed in the previous lecture, that scheme will use disinfectants like chlorine, etc., for treatment purpose, and then that water is circulated to the through the pipeline to the households, right? So de-ionized water or distilled water are basically the types of pure water which are used in laboratories only, right? Potable water is the water that you can drink, right? This is now this is a very interesting topic, and this is basically a thing on which the environmental engineering as a whole is dependent upon. One of the major concerns area for an environmental engineer is the polluted water. So any water which consists of undesirable substances which is making it unfit for drinking and domestic use, that water is your polluted water, right? Contaminated water, there is a difference, there is a very slight difference between polluted water and contaminated water. For example, if you see that there is a mud in water, you can say that it is polluted water, but it may or may not be contaminated water, because contamination means that any water which is having pathogens inside it, right? Disease causing bacteria or germs inside water which are not visible to naked eye, that water is contaminated water. That is what I am trying to tell you, is that a muddy water may or may not be a contaminated water, but a crystal clear looking water can still be contaminated, because microorganisms are so small that they cannot be seen by naked eyes. So what we do is we test this water which is not muddy in nature, or which is apparently not looking contaminated, but we test it for the presence of E. coli, and the presence of E. coli will represent that the water has pathogens inside it, right? So you have to understand that if you filter water, right, so you will not be having any type of physical impurities which can be seen. For example, if you filter water with a filter paper, what you will have is filtered water. That filtered water will not have turbidity, will not have any other visible impurities, but it still can be contaminated. Then that water is to be tested for presence of E. coli, and that will indicate that if water is contaminated or not, right? So contaminated water is also polluted, but the polluted water may not be contaminated, and vice versa, right? So now we are coming to our effluent. Effluent is an outflow of water from a natural body of water or from human made structure, right? Any wastewater coming out from a natural body or from a human made structure is our effluent. Basically, effluent is that polluted water which is going into a treatment system for being treated, and after that effluent coming inside it, the effluent is the treated water that is coming outside from it, right? So this effluent can or cannot be discharged into a river, stream, or a lake or a pond. Can and cannot be discharged, what I mean to say is that our government, our government is doing is, our government is currently working on a technology which is called ZLD, or we can call it as zero liquid discharge. That many of our industries have started to run on zero liquid discharge. That is, the amount of water which is present or which is to be used in different processes of the industry, that amount of water is retreated, and that amount of water is reused within the systems for recreation purposes or for similar purposes. And if that water is to be used for potable purposes, then we'll have to make use of further treatment technologies like MBR and MBBR before we finally can use it for potable purpose. Even if we are not trying to use the water for potable purpose, we can use that water for recreational purpose. For example, for gardening purpose, for washing of boilers, for washing of animals, right? So any of these things can be done with the water that we had initially used as raw water or the fresh water that we had polluted by our actions. For example, if we are washing animals, so for example, even a slaughterhouse, what happens is, or in a leather industry, what happens is you wash off those skins or you wash off those animals with clear quality of water, and when you wash them off, dung and other impurities, biological contamination, all these will carry them carried in with water, right? And when this is treated, then what we can do are two things. We can either release this treated water to a water stream, or we can divert this treated water back to the systems we were using initially. That is, the water can be reused over and over again, and all that water is not going outside the industry. So zero liquid discharge is a very important and very interesting topic that government has come up with. So water quality is the physical, chemical and biological characteristic of water. It is a measure of the condition of water relative to the requirement of any human need or purpose, right? Water pollution we had already discussed. So now the Indian standard specification for drinking water, IS 10500, this has been given in the standard method books that I have sent you. The standard methods is like environmental's main book, right? All the specification that the government of India has specified for different type of water and different uses of water have been mentioned in the standard method. All the tests that we have to perform in laboratories, may it be ambient test, may it be presence of E. coli, or physical tests like turbidity, like visibility. All these tests that we do are mentioned in that Indian standard specification for drinking water, IS 10500. That is the book that is called Indian Standards. ठीक है, तो standard methods book is the Indian specified version, and many of the countries are following the European Protection Agency, EPA, for specification. India is also more or less following EPA with modifications to it with regards to our country's geometrical territory, right? So you can see that what are the required limit, and for example, that color expressed in Hazen units, requirement desirable limit is 5. Above 5 the acceptance decreases. Limit in the absence of alternate source. If there is no alternate source of water and water has a color in it, then up to 25 Hazen is acceptable. After 25 it becomes toxic in nature. That is, the whatever chemical, if water is colored, that definitely means that there is some chemical inside it which is imparting color to it. So if something is imparting color to it and it is to the limit beyond 25 Hazens, then it becomes toxic. Then it cannot be used before treatment. For example, odor. Odor, what is odor? जो बदबू आती, that is your odor. ठीक है, अब वो चाहे अमोनिया की वजह से हो, चाहे कार्बन डाइऑक्साइड की वजह से हो, चाहे किसी और वजह से हो. Odor is an objectionable item for drinking water. Your drinking water should not have any type of odor, right? Different type of taste. Taste is also, if there is agreeable taste, the water should not taste too much, right? If there is taste in water, it is an undesirable effect. Turbidity is in the naphthalometer turbidity unit, NTU, right? So it should not be more than 10. The limit is 10. If there is no alternate source possible, then up to 10 NTU units you can use that water. Beyond 10 you cannot use it before treatment. In case of pH of water for drinking water should lie between 6.5 to 8.5, and it is non-negotiable. So pH should be in this range only. Beyond this range, water will affect the mucous membrane and water supply system also, right? So you can see that Indian standards have different standard for different type. For example, iron should be less than 0.3. If there is no alternate source, then up to 1 is permissible. Chlorides up to 250 milligram per liter. But if there is no alternate source, up to 1000 is permissible. Beyond 1000 we have to treat that water before using, right? Residual chlorine 0.2, उससे ज़्यादा नहीं होना चाहिए. Dissolved solids less than 500. If there is no alternate source, then 2000. Beyond 2000 we have to treat it first by filtration, right? Similarly, calcium 75 to 200 max, right? Copper 0.05, 1.5 से नीचे होना चाहिए. Manganese, it can have manganese, but 0.1 milligram per liter. If there is no alternate source, then 0.3 is possible. Sulfate 200 milligram per liter, maximum 400 milligram per liter, right? Nitrate 50, no relaxation in nitrate. Fluoride 1, ठीक है. फ्लोराइड अब ऐसी चीज़ है कि जो है आपकी फ्लोराइड होनी ही चाहिए. अगर जो है फ्लोराइड नहीं होगी आपके वाटर में, अगर ज़्यादा होगी तो फ्लोरोसिस कॉज होगा. अगर एक डेढ़ से बहुत ज़्यादा चली जाएगी तो फ्लोरोसिस कॉज करेगी, यानी दांत जो है वो गलना शुरू हो जाएंगे, ठीक है. और अगर उससे कम होगी तो फ्लोराइड ज़रूरी भी है, तो वो स्केलेटल फ्लोरोसिस कॉज करेगी, यानी हड्डियों को नुकसान पहुँचाएगी, ठीक है. तो देयर आर a few elements which are also necessary to be present in water, right? So these are the standards for drinking water only, right? You can take a screenshot of these and you can write these down, because such type of questions can be asked for the major. For example, they will most probably not ask कि सेलेनियम कितना होना चाहिए, दे विल नॉट. लेकिन दे कैन आस्क क्लोराइड कितने होने चाहिए मैक्सिमम, दे कैन आस्क फिनॉलिक कंपाउंड्स कितने होने चाहिए, लेड के बारे में पूछ सकते हैं, जिंक के बारे में पूछ सकते हैं. तो जो आपके जो बेसिक चीज़ें हैं वो आपको याद होनी चाहिए. और इस तरह के जो है आपके, और इन सब चीज़ों के टेस्ट होते हैं आपके, ये जितने भी कैडमियम है, मर्करी है, ये सारी चीज़, इनके लिए एटॉमिक एब्जॉर्प्शन स्पेक्ट्रोफोटोमीटर यूज़ होता है, ठीक है. तो टेस्टिंग प्रोसीजर्स आई विल एक्सप्लेन टू यू इन द नेक्स्ट क्लासेस. You can take the screenshot and make a table of these things, because these things will be asked in objective question, not only in these exams but throughout your competitive examinations also point of view, ठीक है. Chromium, you have to remember that chromium as Cr6 plus is the main culprit, right? Cr6 plus is the main culprit, so you have to be sure about the ionic composition of chromium also, right? And now these are for effluent, that for a treated, if we are inlands. अब treated surface का ये है कि हमको किस तरह का यूज़ करना है. अगर पब्लिक सीवेज है तो 600 सस्पेंडेड सॉलिड, इरिगेशन के लिए यूज़ करना है तो 200, ठीक है. इनलैंड सरफेस के लिए यूज़ करना है तो 100, ठीक है. ये मिलीग्राम पर लीटर में है. तो ये सारी चीज़ें जो है आपके ट्रीटेड वाटर के पैरामीटर्स हैं, थोड़ा सा क्लियर नहीं है तो आई सेंड यू, और ये स्टैंडर्ड मेथड्स में भी आपको मिल जाएंगे. तो ट्रीटेड वाटर के स्टैंडर्ड्स डिफरेंट हैं. You can also take a screenshot of these and write it down in your copies, right? So you can find it in standard methods also. So this is what we got up to this point, and after this lecture we will start discussing about the testing procedures for different items. Thank you so much.